Okay, so this first short video will be on angles in standard form. So a lot of you are familiar with angles. You probably use them in skiing or to describe things, like doing a full 180 when you change your life around, or 90 degrees, being perpendicular. We've done all this with graphing, but we're going to do them in standard form. And what that means is that we're putting them on a coordinate plane, and your first bullet point on your guided note sheet says an angle on the coordinate plane is in standard form when the vertex is on the origin. So that means that I'm using my origin, or point 0, 0, as a reference point, and one of the rays lies on the positive x-axis. So this is one of the arms of the angle. This is the positive x-axis. My x's are positive here. My x's are negative on this x-axis. So we're using this as a reference. And this ray on the x-axis, so this ray on the positive x-axis, so ray on x-axis, is known as our initial side. So that's your first blank. So the ray on our x-axis is known as our initial side, and then when we draw our other ray to give us an angle, which would be here, this other ray is known as our terminal side, or our terminal angle. Terminal ray, I mean. So you can either use the phrase side or the word ray. So this gives us an angle, and when we use the coordinate plane, we can either go in the positive direction, which is counterclockwise, so this is a positive direction, or you can go in the negative direction, which is clockwise. So when we're measuring angles, they either go counterclockwise positively, or clockwise, which is negative. So counterclockwise positive, that's your next fill in the blank. This is counterclockwise, and then clockwise is negative. All right. So the most common unit that we use for describing angles is the degree, which you abbreviate with a little symbol like that. It's their little degree symbol. So you can fill that in. So the most common unit is the degree. And each degree represents 1/360th of a full rotation. So 1/360th of a full rotation. Because a full rotation, remember, or going around in a circle, is equal to 360 degrees. So 1 degree is 1/360th of a full rotation. Okay, so what I want you to do now is look at the questions below. So you have 1 through 6, and you're sketching an angle in standard form. It gives you a reference circle to the left that includes the angle measurements at the different points in the coordinate plane. So at this point on this x-axis here, this is at 0 or 360. So if I had my initial ray and my terminal ray in the same spot, that would be either 0 degrees or a full rotation at 360. So if they lay on the same line, that's 0 or 360 degrees. If I have a ray, so my initial ray here on my positive x-axis and a terminal ray that's perpendicular to that, that's at 90 degrees. If I do a line that's continuing into the negative x values here, this is 180 degrees. So like 180 is in the opposite direction. And then 3/4 of the way around is at 270. And you can go above 360 in both the positive and negative direction. It would just bring you past that 360 degree mark at the initial ray. So let's look at number 1 through 6 very quickly. These graphs are fairly light, but if we look at them, let's see if I can get this to show. There we go. So we got 65 degrees here. So I'm using my initial ray at the positive x-axis, and then I know it's going to be slightly less than 90, which is here. So I know it's going to be more than halfway. but not quite at 90. So I'm going to draw something that looks like that, and it's in the positive direction. So I'm going to draw an arrow that represents it's moving in the positive direction. Number 2, we've got 320 degrees. I don't know if you can see that, it's very light. So again, I'm going to draw my initial ray here, and then it's not 90, it's not 180, it's not 270, and it's about it's about halfway between 270 and 360. So I'm going to draw my terminal ray here. So this is about 320 degrees in the positive direction. In number 3, I've got 415 degrees, sorry. So that's going to go beyond 360. So I'll still draw my initial ray here on the positive x-axis, and then I'm going to calculate how much further. So I'm going to do 415 minus 360. So that's about 55 degrees beyond. So it's less than 90, and it's a little bit more than halfway. So I'm going to draw it here, and what I'm going to do for that is I'm going to draw a full spiral like that. And that would represent 415 degrees. So I went 360, and then I went 55 more in addition to that. So number 4 through 6 is where they get negative. So if I go negative 140, I'm just working in the opposite direction. So I'm working counterclockwise. So I still draw my initial ray, and I know I'm going beyond negative 90, so you can work backwards. So this would be negative 90, this would be negative 180. So I know I'm not quite at negative 180, and I'm about halfway between 270 and between negative 90 and negative 180. Because the difference there, I have 40 left over. So I'm going to continue close, but not quite there. So this would be negative 140. Okay, so then negative 15. Maybe you're all getting the hang of this. Negative 15. Draw my initial ray there. And then this one's going to be very tiny, like that, my terminal ray. And you can draw a little clockwise arrow going in that direction. And then finally, number 6, we got negative 210 degrees. So we're going negative 90, negative 180, and then we're going about 30 degrees beyond that. So we'll be going a little bit, like a third of the way between this axis and this axis, and that will be my negative 210. To draw my initial ray. All right, the next video will be on radians and converting radians to degrees and coterminal angles. Thank you.